out there. So first of all, to put a context to this solution, why exactly did we go about building this solution? What were the kind of objectives that drove us, right? So first of all, if you can focus on the left-hand side, there is something called as a conveyor belt. I don't know how many of you are familiar with this concept. So some of our adversarial elements out there, specifically a country to the northeast of India, is running something called as a conveyor belt of intelligence, right? So what exactly are the components of this conveyor belt is that essentially they feed these raw data sets, right, which are gathered by their boards and the vectors that are operating to exfiltrate this information. It is essentially fed into these systems, these intelligence processing systems that are co-opted from private entities, right? You have some very big names operating in that country who are forced to actually take this data into the big data processing systems and churn out processed intelligence, and that data is again used to retarget the very systems from which this data has been collected, right? So there is a essential conveyor belt that goes in. So what we figured out is that to break this conveyor belt, I mean, of course, there are countries which are not running these belts at this efficiency that this particular country is doing, but we figured out that we have to do a lot more, right? We have to play the enemy on their own terms and essentially make them feel as if they are winning and they are getting what they want, right? So that was the fundamental premise on which this whole solution was essentially built. So now if you look at defense assets out there, communication infrastructure and everything else, in the real world, everything is exposed. At some point or other, you will definitely be encountering a sort of a situation or an event or an episode where there will invariably be a breach. But the question that arises is, what can the adversary gain out of that breach, right? How much can they pull out from that breach and sort of use that very information against us, right? So in the real world, when everything is sort of vulnerable, how about if we turn that around and build a entire spoof, digital world out there, which is real to the best extent possible, right? And which is not just real to the best extent possible, which evolves according to the methods and the kind of tactics that the adversary uses to target us as well, right? So we are talking about an active decoy solution. That is essentially what the solution in fact does, and we'll get into the details now. So it essentially presents as cross-spectrum spoofing, right? So if you look at a scenario of a hybrid warfare, or if you're looking at a conflict that has multiple dimensions, not just in the real world, but also in cyberspace, that is where this decoy comes into the picture. This decoy solution essentially comes into the picture because you can spoof all the elements that we have listed down there and go beyond that, right? You can in fact do a level of calibrated force posturing. By that what I mean is that you can actually present your strengths in a much more amplified way to the adversary, right? Now that is going to be interesting. Now look at an adversary who's coming in to gather intelligence, gets spoofed by this, gets taken into a different world altogether, where there is zero intelligence of value, where they get inside and they get confused, first of all, to begin with. They get a wrong sort of image of our actual capabilities, and they get junk intelligence essentially, right? All that is possible with this solution, right? And look at what an enemy or an adversary essentially is looking at drawing from from the intelligence that they're collecting from our systems and our networks that they're trying to penetrate into, right? There is definitely electronic warfare at the core of it, which includes all the hardware and assets which are connected. They want to degrade our situational awareness, right? They don't want us to evolve into a situation where they can where we can actually assess them much better than they can assess us, right? So they want to degrade our situational awareness. They want to gain freedom of maneuverability in cyberspace, right? That's another very interesting point there, which essentially is they want the cyberspace to be brutally uncontested, right? So that whatever they do is not challenged by us at any level, right? That's another point that I wanted to bring in and reinforce the effectiveness of ground maneuvers. So essentially, as the conflict intensifies, every single tactic has to be amplified by the adversary, and we have to counter those very tactics, right, with our own sort of maneuvers and tactics. So the calibrated force posting that I was talking about, right? So here you are in full control. You as an armed force entity are in full control of what kind of force do you want to project to the adversary, right? If you want to confuse them and you want to give them a sense of inferiority, saying that make them feel overconfident about themselves and feel bad about our capabilities, you can do that, right? Or you want to amplify it to the other end of the spectrum, right? Where you want to show them that, we are more capable, we have more assets, we have more sort of, systems to counter them, be it in the electronic space or in the real world, you can actually do that. But what this solution gives you is, it gives you that full control that is essentially required to, to allow the enemy to, project an image of you the way you want them to, right? What could be better? So any kind of conflict scenarios, all the speakers have spoken about multiple situations where they're coming in, we have X number of attacks happening, we are the most targeted country and everything else. This is the one solution that can bring us closer to victory than anything else out there, which is why, NASCOM called it a game changer as well. So again, multi-domain operations across any domain that you can imagine, we can create these spoofs on the go, and I'll explain how exactly the solution works so that you can, get a good picture of how exactly all this is done. So any domain you take out there, land, sea, air, or digital space, cyberspace, contested spaces, non-contested spaces, dark web, this can apply anywhere. But essentially what you're doing is you're just tricking and fooling the enemy. And these are the kind of gains that you can expect, right? You can compete, contest, contain, and consolidate as well. And more importantly, that contain part, wherein you can actually force the enemy to focus their tactics into areas that you want them to focus on, or where you can defeat them much more quickly. You want them to gain a wrong impression about your capabilities, that again can be done. You want them to sort of you want them to influence their maneuvers and drills by giving them wrong information and data sets. That again is possible with this solution. So these are just limited gains, because the spectrum can be infinite. If you go on adding more domains, and if you go on adding more sort of use cases, so to say, which I'll again cover in the next slide, you will see a lot of other things, other gains coming your way as well. So this solution is still in its nascent stage as far as its utility and the kind of use cases where it can be deployed is concerned. But for all of you sitting in this room, I can already imagine all of you thinking about the kind of use cases that this can be put to, right? So some of the use cases that we could think of as far as the solution applicability is concerned. But of course, as I said, it's way more than that. If you can look at, you can even train your resources, right? You can actually, and how do you train the resources? When you see an adversary enter into your simulated environment, right? Through a vector, through a malware, or through an infected payload, and you see what exactly are they doing in that environment, right? What systems are they targeting? What assets are they going after? What kind of sniffing are they doing? What kind of packets are they trying to exfiltrate? You already have a lot of data sets that you can use to train your very resources, who can defend your cyberspace against these very enemies, right? Converged countermeasures, again, you will understand what are the top priorities that the enemy is working with in cyberspace. A lot of these are X factors, for us today, all of us sitting in this room, right? Because we are not completely aware of every single capability that exists in the enemy, because sometimes a lot of their attacks slip below the radar, right? We are not able to sort of track every single attack that they draw in, or the scans that they do on our networks. We are not able to really capture it, right? So we need to, with this solution, with the infinite possibilities and spoofing scenarios that it offers, gives you much more control and much more flexibility to deploy those use cases and sort of influence your enemy as well. So this is in a brief. Again, it's a compressed way to present the capabilities. So what it does essentially is that we have these spiders, which are nothing but they have been trained. These are captured web spiders who we have converted into situational awareness spiders. Essentially, when we deploy them on the network, they go across the network, they study the network topology, what devices are connected, what kind of infrastructures exist across those particular networks, and they start building the spoofs of those very networks and systems. So it's all automated again. Nobody needs to program these boards into creating those very digital spoofs and infrastructures. And suppose hypothetically, if there is an attack happening, then a different scenario kicks in. I got another slide on that. But here what we have to understand very clearly is every single step is automated. So right from creating these infrastructures all the way up to multiplying these infrastructures manifold depending on the vector that comes in, depending on the payload that comes in. If it's interacting with this particular part of your infrastructure, then you want to extend that infrastructure in the digital spoof space, right? You want the enemy to focus more on that and continue engaging them there. Because one of the objectives of this solution very clearly is to ensure that we keep them tied down, right? We don't want the enemy to gain situational awareness and contextual awareness about us. And second is that we want to confuse them as well, right? So both the objectives are being met here. And yeah, that's the award that we won last year from NASSCOM. So we were voted as the game changer in the cybersecurity category across the country, across all the solutions and concepts that were pitched. In fact, so this solution deploys something called as an active spoofing, which is quite different from the honeypot networks and all, which you might be tempted to equate this to. This is way beyond any normal honeypots or anything that can even come closer to that. So unlike passive spoofing, where your ability to mimic the infrastructure is pretty much limited to what you already have, in active spoofing, which is what this solution runs on, you can spoof at infinite levels. You can add even components and infrastructures that you don't currently have in your network or elsewhere, right? And it gives you that operational flexibility and maneuverability to ensure that you can continue spoofing at levels that you wish to and keep the adversary engaged forever, right? And you can even target the C2C command and control communications that the malware must be or the vector must be carrying on. Even that can actually be targeted using active spoofing, whereas passive is pretty much limited to the current infrastructures that you have, and there's no communication layer essentially that is out there. So this is what happens when a vector comes into the environments where these spiders are active. So what they do is they start observing the behavior of the vector in the network, and then they start sort of building the spoof environments and see which triggers are or rather which behaviors are triggering more interest in the vector, and then continue keeping the vector engaged in that. So assume if there is not a single payload but 1,000 payloads come in at the same time, the spiders can split and target each one of those vectors independently, right, through a different space altogether. So all said and done, this is the scalable decoy and deception solution that we have come up with to really solve these very problems that we have spoken about in today's session so extensively, right? And nothing even comes closer to this, not just in India, even globally. If you look at it, if you look at the whole spoofing space, everything is pretty much in the passive domain, right? Which we have left behind long back. So we moved on much further, and these are the specific capabilities that I'd like to leave you all with as far as the solution is concerned. In the interest of time, I'm not doing a deep dive, but if any one of you are interested and would wish to talk to us a bit more about this and understand the solution and see its specific capabilities, I am here, and I'd love to sort of hear from you in terms of if there are any features that you missed out or anything that you feel should be there in this, please let us know, right? So thanks again, wonderful audience, great show. Thanks Kaushal for having us here. See you all.